obviously
Yeah.
keep it quiet so you don't disrupt those flows. All right. Did you have a specific question about this, or let me just go through it? Just go again? Okay. All right, so this was back in gene regulation. Seems like weeks ago now. Yes, it was. All right. When we talk about gene regulation with respect to bacteria, the most famous old conceptual idea that gets taught that I learned when I was in college is the lac operon. Lactose degradation is really just a bacterial process. Okay? And it's an optional process. So it gets put on an operon so that it can get regulated. Alright? So, something we talked about with respect to lac operon, if I'm a bacterial cell and I'm floating in solution in some sort of media, and I have glucose available to me and lactose available to me, what do I want to metabolize first?
Glucose.
Glucose. Excellent. All the glucose gets used up, then what am I going to do? Switch to lactose. Absolutely. Excellent. Okay. And we called that dioxic growth. Right? The point being, you have an operon that regulates this. The lac operon is under positive control and negative control. If you guys tell me, I don't have a test next week, you tell me, when is it under negative control? What's the negative control aspect of this? So let's think through it logically. If I'm going to degrade lactose, if I'm going to chop up that sugar and eat it and get energy from it, I need to create a whole bunch of enzymes to digest this. All right? So, if lactose is not present, do I want that operon on or off? Off. Good. Okay? So that would be under negative control. Okay? So, in other words, if lactose is not present, in this case, look here, neither lactose or glucose is present, but just stick with the lactose now. Lactose is not present. So that repressor, cleverly called a repressor, nice intuitive word, is bound to the operator site so that you cannot transcribe that operon. You're not going to go to the trouble to make all those enzymes to degrade lactose. Okay? So that's the negative control. All right? Positive control. This is hard. This is a good reason you guys want to hear it again. Positive control is associated with glucose concentration. In what way? One of you guys tell me. Tell your friends. Don't besides Mike. No disrespect. CAP is active or inactive when glucose levels are high?
Inactive.
Inactive. Good. Okay. When glucose levels are high, what is this thing going to be doing?
Breaking that glucose.
It's going to be off. I'm not sure who said it, but you're right. Something about inactive. Good. When glucose levels are high, CAP is inactive and it's not on there. All right. So the reason this operon is under positive regulation when glucose levels are low is because glucose levels are low, CAP is active, it binds to the positive regulator site. Okay? The site. All right? And turns it on. All right, so let's just step through these four panels. Okay? So, we have lactose present, but no glucose. Okay, and feel free to cheat me with this slide. Lactose present, no glucose. Lactose is present, so is the repressor on? Is the repressor bound or unbound?
Unbound.
Good. The repressor is unbound because lactose is present. Absolutely. No glucose is present. No glucose is present. Is CAP active or inactive? Active. Good. CAP is positive regulation. Positive means turn that thing on. Having the repressor off is the removal of negative regulation. So this thing's on. Okay? And it's on because, very logically, you have lactose available but no glucose. Okay? So let's turn this thing on. Let's make some enzymes and let's eat some lactose. All right. The transcription occurs. All right. In this situation, we have lactose present and glucose present. But again, what did I say you want to eat first if you have lactose and glucose?
Glucose.
Right. Absolutely. So because glucose is abundant, CAP is inactive, inversely related. But you have lactose present, so that repressor's not there. But as I've said, positive regulation and the negative regulation have to agree with each other, basically. And cap tends to trump. So without that positive regulation, even though we have lactose present, we don't have cap bound to that site. So you get no transcription. All right? No transcription. So let's just think through mechanistically, like you're inside of a bacterial cell. So now you've got lactose and glucose. I'm gobbling up all that glucose. As I gobble up glucose, what's going to start happening to cap?
It's gonna start getting
It's going to
closer to
become active, and what's it
capsids.
going to do?
Start breaking down glucose.
Transcription, but to transcribe, what's cap going to do?
Bind.
Bind to the capsid. Bind to that positive regulated site. Going to give it positive regulation now. Turn that thing on, and then you're going to get transcription. All right. Okay. So in this case, again, let's go through it. Neither lactose nor glucose. I have no lactose present. Therefore, the repressor is bound to the operator site. I don't have glucose present, so I have the positive regulation of the cap. Okay? But I have no lactose, so who cares? Don't turn it on. Notice the repressor site is downstream from that positive regulation site. So having the repressor in place shuts it off, even though we're under positive regulation of the cap. That repressor still shuts it off. Okay. So we have glucose available, but no lactose. And this obviously makes sense. We're going to degrade that glucose. No lactose available, so the repressor is still bound. We have glucose available, so cap is inactive. So that's not there anyway. It doesn't really matter. It's not gonna tell you no lactose. All right. So one more quick little important point that I think gets at something you were wondering about. If I'm wrong. What turns your repressor on and off?
The allolactose.
The lactose. What about the lactose?
The
Remember, this is a
allolactose.
detail, some detail, but if you know it, you're in good shape.
Allolactose.
Some of you out there saying allolactose. Who said allolactose? Raise your hand to be strong. Okay. What about the allolactose?
The allolactose binds to the repressor site.
Turns it off. Absolutely. Okay, so it's just a feedback regulation. Allolactose binds to that and turns that repressor off. So when you have a little bit of lactose around, you produce allolactose as a byproduct of that. That allolactose is what binds your repressor to shut it off. Okay. That help? You have a
Yes, so
specific question?
in that case, it starts to make more those primates and beta-glucose.
I'm sorry?
In that case, when the repressor is off,
Okay.
the
The repressor's inactive, you mean it's off of the.
the RNA polymerase binds to that spot.
Yep.
It starts to producing that RNA. The RNA comes out. In that case, when the RNA comes out, those ribosomal RNAs start to produce those proteins.
The ribosomes attached to this RNA,
Yeah.
absolutely, so to produce.
Those proteins,
Mhm.
and after that, those proteins bring more lactose into the cell.
But proteins aren't bringing more lactose into the cell,
Yeah.
lactose is getting into the cell and then it can degrade.
Yeah, so in that case, when those more lactose in the cell, those lactose again, the other protein, the beta-glucose, breaks down those to make the glucose and the other one.
Yeah,
And in that case,
that is glucose levels are gonna rise, but they're also in theory metabolizing that glucose.
yeah, so what happens that repressor again binds to that, because now we have a lot of, okay.
So it's better.
Yes,
Anyone else? Yeah, Ms. Bird.
Are each of these either positive or negative control, or some of them a combination?
So, I think the way to answer that question, kind of a crappy answer, is this operon can be under positive, negative.
Okay.
Okay, so when it is positively regulated, it's being positively regulated here. By CAP. CAP is a positive regulator. What I mean by that is when CAP is bound, the thing is on. When CAP is off, the thing is off. Negative regulation comes here with the repressor, because when the repressor is bound, the thing is off.
Okay.
Contrast that with CAP. Okay. And when the repressor is off, the thing is on. That's really cool. All right, good questions. Yeah, we are.
Is cyclic AMP what turns cap on or off?
I'm sorry?
Is cyclic AMP what turns CAP on or off?
Yes. The
So that's like a
cyclic
signal
AMP
kind
the
of-
cyclic AMP is actually what's in proportion to glucose concentration.
Okay.
New message from Babylon, asterisk.
All right. Okay, so do some studying over the weekend. I will get your questions up by tonight. Bed.